thanks to Adrian, he's not here. But yeah, huge kudos to him for putting this together. It's amazing that we could gather here, and we have a lovely event. I have a great opportunity to talk to you about a topic I consider rather important, and it's about how Ethereum is developed. So yeah, about me, I'm Mário. I'm from Ethereum Foundation, protocol support team to be specific. And in protocol support, we are supporting the protocol, supporting the devs, the core devs of Ethereum. We are helping to facilitate actually the Ethereum upgrades, the hard forks of the network as we call them. And in this talk, I'd like to talk to you about how this development actually happens, what are all the technical parts to Ethereum, and also a little bit about the roadmap, what we plan ahead. But first of all, also about history a little. Because to understand Ethereum design principles, you need to know what prehistory we are building on. And it's you can find slightly off topic, but I find it very important because you can find fingerprints of all of this in today's Ethereum design. And first of all, Unix. Unix operating system. I love this documentary. This is a video on YouTube, which I very much recommend you check in. It's a documentary from 1982 about how the Unix operating system is developed. There is Richie, the creator of C, talking about how he creates the Unix with C language, and it's just amazing. And why I'm talking about it because Unix created a computational paradigm that we are using till today. These people invented the computer as we use it today. In a way that they brought us this, I would call it Unix philosophy. It's a philosophy of development to approach to software, which is rather modular than building a cathedral, which means that the Unix was developed in 8080 labs, in Bell Labs, also with contributors from like MIT and so on. All of these people were working on their own part, their own piece of software, which was specialized doing one thing, not like one huge monopoly of one thing, but separate pieces, which in the end come together. That's Unix philosophy, to have your system modularized, not trying to do everything at once. And this allows for very effective development, but also the Unix project was very unique in a way how these people collaborated on it. Talking about the Bell Labs and so on, like everybody had open door, everybody was talking, somebody working on a different project for the same platform, they talk to each other, they make sure that these things work together. And this sort of collaboration and these design principles we see in Ethereum today. And speaking about like openness of Unix, like it was kind of open to these researchers, to these developers, but it was not truly free and open operating system. That's why we have Richard Stallman. That's why we have the GNU project. So later in the 80s, we have Richard Stallman starting the GNU Free Software Foundation, right? Defines the what institutes the free software, the freedoms that we have to have as users, because well, the computer that lies in front of us, that's a generalized tool. It's a calculator. It's a piece of hardware which can do anything, right? But if we are running a proprietary software which you don't know what it does or you cannot fully control it, it's like you don't own your computer. It's like you own a house and you don't have keys to basement. If you want to change your pipes, you need to call the landlord to change something for you, right? And you don't really own the house then. You don't really own your computer if you don't run free software. And in cryptocurrencies, in Ethereum and all of the others, it's extremely important. It's like the fundamental principle that we have the freedom as users to be able to read the code, to audit it, to even copy and modify it. So we have so many chains out there because it's all copies of Bitcoin and Ethereum, right? But this is a fundamental one of the fundamental principles. So free and open development. And in the 70s, we have the invention of public key cryptography or the asymmetric cryptography. So like for hundreds, thousands of years, people were using encryption in a one way, right? We had a single key encryption where I want to encrypt something to you and I need to get you the ciphertext, the encrypted data, and the key. But with thanks to Diffie and Hellman, we have this technology which enables us to have pairs of key, the public and private key, which can use your public key to encrypt a message which can be decrypted only by your private key. This allows secure communication, and first time we see with the spread of internet, we see encryption of data, encrypted communication on a user level, not like some military whatever implementations, but really the normal users are empowered to use this sort of technologies. And the public keys, public key cryptography is what the cryptocurrencies are based on, right? So the signatures for your transactions, it's all based on this. And with the cryptography being emerging, and computers, and personal computers, and internet emerging in 80s, 90s, the cyberpunk movement grows. The cyberpunks were a community of people, a movement, which was defending these technologies because the cryptography was under attack. The government saying that this is something which cannot be used by individuals, it's something which is military grade, and they wanted to regulate encryption in US, in Europe, and so on. And these people stand against it. So here is Gilmore, creator of Gilmore on the right, creator of the EFF. We have EFF T-shirt right here. Right? So, so one of the founders of EFF, right? There's a great story how he met with Barlow because of the Grateful Dead. But yeah, it's for another day. So yeah, Gilmore, Eric Hughes, author of this manifesto in the middle, and Timothy C. May. So the idea of cyberpunks was to create these tools, to embrace the possibilities that we have with more powerful computers, with this powerful cryptography. And Timothy C. May takes it a bit further. Timothy C. May talks about not just defending our rights and building these permissionless technologies, but we can leverage them to actually achieve freedom, to actively achieve freedom. Because the government or the corporates and so on will always control the physical world. They will always have the policemen on the streets and whatnot. But in the digital realm, they cannot fight with math. They cannot break mathematics and the tools of crypto anarchy. So he talks about crypto anarchy as an advancement to this, and this is something which inspired many people to create things that Ethereum, Bitcoin are based on. So like David Chow in the 90s creating DigiCash, right? Nick Szabo and ultimately Satoshi Nakamoto in 2008 creating Bitcoin. So the question on top of this is, what is Ethereum? Like we see this great story, these people working on technologies which slowly get us all the way to Ethereum. And I question for you, my all the audience is, what is Ethereum for you? What is Ethereum? Any ideas?
CryptoKitties.
CryptoKitties, I love that. No, Ethereum is protocol, Ethereum is love, Ethereum is future. I always hear so much.
Virtual machine.
Virtual machine, that's great. That's great. Something else?
Ethereum is the hand that will help us raise a big middle finger to the world police.
I love that! That's okay, one of the best answers. I can remember that. I love that, thank you. Okay, okay. So in this talk, I need to be technical. I'm talking about development. So like, let's talk more hands-on, right? Ethereum starts as an idea. As every research, every project, and all of the upgrades I'm going to be talking about, it starts as an idea or a research project. And this was written down to a white paper by Vitalik, 2013, 2014. Yeah, look at this keynote at Bitcoin 2014. That's lovely. So, so it starts as an idea, and the idea is written down by V, and then by Gavin, it's actually specified. It's the yellow paper of Ethereum is creating the technical specification, right? So we come from idea, this is how it should work, to this is how it works. So like exactly all the math, all the algorithm explained exactly how it's supposed to behave. And Ethereum is specified not just in a yellow paper, but then in EIPs, in the improvement proposals. Because Ethereum is a community project, Ethereum improvement proposal is a community way of how it gets updated. Some members of the community propose EIP in a given template, and the developers can discuss it and decide to include it. So we have some some specification of Ethereum in the yellow paper, some in the EIPs, but it comes all together in the execution specs and consensus specs. So finally, we have also the execution specs done. This is in Python, and these are executable specs. This is the basic implementation of those specs. Exactly written down examples in Python how it's supposed to work, and this is used to generate tests that all the protocol is working the way it's supposed to. So if you're interested to look what exactly Ethereum is supposed to do, these are the repositories where you can find that. Yeah, also for APIs here. Okay, so talking about the story of Ethereum, just about these upgrades of these EIPs, they come together in some upgrade. We call them hard forks or updates of the network because they require all of the users who are agreeing with these new changes in the protocol to update their node. The latest one was Shanghai in April. It goes all the way back to Homestead Frontier in 2015-16. And all of these upgrades are built on the original visions. The Ethereum design, as envisioned by Vitalik, Gavin, and the 6 other founders, is supposed to be Ethereum is supposed to be simple, universal, modular, don't discriminate anyone, and agile. So these are some few principles, few ideas of how the protocol should always move. The developer should always look up to. Basically, what it means is like, well, keep it simple or relatively simple as you can. It needs to be universal. Like Ethereum, it's not supposed to. It's also here in the neutrality and freedom. The idea of Ethereum being universal and neutral means that like it's not built for a specific purpose. It's the virtual machine. It's the computer. It's there for everyone, and it's up to you what you build on top of it. It's not leaning towards certain features, and it's universal in a way that like also the developers or the core platform doesn't dictate on how these applications are supposed to be working. So there is not like some defined way how tokens are supposed to be built on Ethereum. There are community standards like ERC 2071, 1152.5, and so on. And these are just created as the Ethereum went on top of it, not within it. Yeah, it's modular. I'm going to show it soon. Doesn't discriminate against any specific use case. And so I mentioned the simplicity, and many people would argue that Ethereum is quite complex. And Ethereum is managing its complexity thanks to 2 parts. It's encapsulated complexity, which is basically the modularity. So Ethereum is actually in 2 main parts, which have some subparts, and they encapsulate the complexity in a way that it's like some module which communicates to the other over a simple API, simple interface. So if there is if you see issue, it's in one of these modules, and you know that the whole thing is not broken down. You need to fix this specific part. And the sandwich complexity is basically how Solidity works, how Solidity language or the virtual machine was designed in a way that when we use applications in Ethereum, we have the Solidity or Viper or Phi code, like the readable code by programmer, which is auditable, readable, then goes to the complexity of the compiler, and it spills out bytecode, which is like 30, 40 opcodes, and it's again mathematically provable, auditable. So we have the simple parts and the complexity in the middle. That's how the sandwich complexity works. And yeah, and the last part in the development, this is important. This is something which the developers take afterwards. Like the devs or the community is not worried to take risk if it's worth it. So it's not scared of any risks. But if there is what I talk about here, the upgrades in the network, which might cause issues because, well, we are changing the code of the network, comes with certain risks, but also gives us a bunch of features. So we consider it worth it if the risk is manageable. So yeah, these are some design principles. Now, how Ethereum, I will just go fast through this because I don't want to bother you with details, but this is my rough sketch of how the Ethereum looks from the highlight. The important part to take from this is like after the merge, after Ethereum went to the proof of stake, it's basically two parts. Ethereum is two networks, one managing the consensus and the execution. The execution layer is what Ethereum used to be, basically just executing the transactions, keeping the state. So we have the state data in Ethereum, which are executed by, the transactions are executed by EVM, which updates the state. And this is what you talk to. If you use Ethereum, if you use Ethereum wallet, you're talking to execution client. If you are a validator or somebody who cares about the consensus of the network, you talk about to Beacon API, to Beacon node, and the Beacon node using fork choice is always telling the execution engine what is the latest head. We basically have Ethereum in these two parts now. This is how it looks, a bit more simplified. So we have the execution engine and Beacon node talking together over what we call engine API in two separate networks. So this is the modularity I'm talking about. We have two main parts. So if one of them breaks, we see that we can debug it using the engine API, and each of them have their own little parts. Each of them have their modules. And implementation. So like this is the theory still, and this is written down. This is actually programmed by some crazy people. There's like 200 of them doing this. And on the execution layer side, these are the clients. Most of the network is running Go Ethereum with like 30% Nethermind, little bit of Besu, and a little bit of Aragon. That's the current. And the Rust, the red is the newest client made by Paradigm. It's a huge VC. And just one thing I would mention here is that really a lot of not just the network upgrades, but just upgrades in the client architecture itself is happening over the years. So, for example, Rust, the get is the most used client, the most, I would say, most advanced in a way that it was developed a long time. It's very effective, very optimized, and very like senior client. And this is the newest client, which is using faster language and new approach to the client architecture. They rethink how the whole database works, and they ended up being like 20 times faster and 5 times smaller database, which is incredible, right? They managed to optimize the shit out of it. So they actually like took it from Aragon. It's another thing. So like these are the clients, the actual implementation on the execution and consensus layer side. So if you are running validator, if you care about the consensus, these are the implementations, just like examples you see. What I want to show here that you notice the different languages: the Go, Rust, Java, TypeScript, Vim, C#, whatever, TypeScript, JavaScript, C++. So we have different implementations of the same thing. This is again like one of the principles of Ethereum development, that we don't have like single implementation, but we have these specs, so anybody can create their code which can be tested against the specification, and we make sure that all of these different code bases talk together in one Ethereum protocol. And if there is a bug, if one of these developer teams make a mistake, the whole network won't go down, because there is no mistaking. Like, so if we have 25% of the network on each of the client, only 25% of the network would go down, and it would still finalize. The blockchain would still go on happily, and we are chill. So that's the approach of the diversity. And now I mentioned that they are tested against some specs. There's a lot of testing in Ethereum. It's more technical. I don't want to bother you with this, but there is like the specification tests, fuzzing, and Hive is a very cool tool. It can spawns all the different clients and connects them and tests them that they all work together in all various scenarios. So there is like heavy testing infrastructure. This is not all of it. What are we doing? Our DevNets. So for the upcoming fork, we have like DevNet number 8. Number 9, DevNet 9 now. So like another test nets which are spawned just to test some specific upgrades, some specific features, and so on. A bunch of testing, because when you have all of these different implementations and complex code bases, you need to be able to heavily test it and make sure that those $500 billion to networks doesn't go belly up. And this is all coordinated in developer calls. two main calls are called ACD, All Core Devs, every Thursday. First week it's execution ACDE, and second week it's ACDC. All Core Devs Consensus. So like those are the two main meetings. But then there are other like ad hoc or specific feature, like for EIP 444, for launching testnets, for EF implementations. Those are happening around these weeks. The EIPs are discussed in Ethereum Magicians Forum. So it's a forum where everybody can just come, propose EIP, discuss it, community manages it. Ethereum cat herders, it's hard to herd cats, and they are trying to do it because the developers of Ethereum are kind of like use cats. And they run the EIP, which is meta for the Ethereum, for the EIP process. A lot of discussion is happening in our Discord. Basically, all of these topics are coordinated in the one Discord server, and a lot of like research, but also technical discussion is happening in the ETH research. So this is basically how it's coordinated. The calls are chaired by Tim Baker, who is working with me in protocol support, and you can find all of the calls in Ethereum/PM as a project management. So here are like archive of all the calls or all the developer discussion in Ethereum ever. So the idea here is that it's completely transparent and open to anybody. It's kind of meritocracy, technocracy, so like who comes and understands the topic and can talk on the topic is welcome to join. And this is how it looks, bunch of devs talking about stuff. This is how it looks when they meet in person. So like when there is a lot of work, sometimes we meet in person. It was in Greece 2 years ago, this was in Austria, January of this year. It's it's funny picture. There's right? So sometimes it's important to actually sit down and work together. So there's like literally 100 developers here who met for a week and managed to put together, in this case it was Chapella, the withdrawals of the merge of the proof of stake. So all of these development cycles work in a same way. It starts with research or some idea, which gets specified. Again, the specs are researched, are tested, are verified their feasibility, their benchmarked, like what whether it's feasible to do it this way, and then it gets developed and actually implemented in the clients and heavily tested. So this is a development cycle which is happening with each upgrade and every EIP which is like seriously considered. And talking about that, what is the current research and roadmap of Ethereum? What is actually happening in the development right now? Because right now we have some exciting stuff upcoming in coming months. Dencun will be activated. Dencun is so upcoming hard fork, upcoming upgrade of Ethereum, major upgrade to the network, which will change many important things. It's Deneb on the consensus layer and Cancun on the execution layer. Together it's Dencun. Yeah, the names are always funny. And the main part it brings are blocks or block carrying transactions, enabling so-called it's proto-DAG sharding. EIP, the opcode for transient storage. Transient storage is EVM opcode, which enables more effective handling of storage. Basically, you save gas, you have some cooler operations. This is dependency of Uniswap v4. So the new Uniswap version will be deployed after this goes live. Self-destruct will be duplicated. If there are any devs here might be interested that we figured out how to get rid of self-destruct in a way that it doesn't break many contracts, just for you, like as little as possible. And more stuff, smaller changes. But I want to talk about a proto-DAG sharding because it's important stuff. Because if you are around Ethereum for a while, you have heard about sharding. A few years ago, or like since the beginning actually, since like 2016 or something, 15, we've heard about sharding, execution sharding. Then it became data availability sampling. And it's always sounds like very theoretical and whatnot, but now we have this, the current specs of the sharding are called DAG sharding, based on DAG files to put it together. And Proto Lambda came up with this concept, which is like one step towards the full DAG sharding. and because of proto-lambda, we call it proto-back sharding, it creates a new kind of transaction. Why? Because the current rollups, the layer 2s on Ethereum, the optimism, arbitrum, zk sync, you name it, what they do is they just spam Ethereum, right? This is how the Ethereum looks like, and also its execution, and they just put their data to Ethereum state using so-called call data function. They are just storing the data in a very, I don't want to say naive way, but it's like not effective because it's not meant for it. So it's just like storing a bunch of data and then enabling you to verify its validity. And what proto-back sharding does is that it introduces new kind of transaction. It's called blob carrying transaction. It has a blob as a sidecar. You know, you have a motorbike and you have a dog in a sidecar. That's the blob. So we have this sidecar, which works in a way that now the rollup, instead of just putting the data to Ethereum itself, it creates a KZG commitment. It creates a commitment to some existence, some integrity of a certain blob of data, and this blob is stored in the beacon chain, but it's ephemeral. It's only going to be there for 4 weeks. And since the rollups enable some challenges only like 1 or 2 weeks old, that's more than enough. We don't need to store their history. And this is a more effective way how to handling for handling the layer 2 data, because they are ephemeral, they are handled just by the commitment, which is a precompile. It means that like there is no EVM execution which would take a bunch of gas and require your node to do a bunch of computation. And the layer 2 can just use the commitment to verify the integrity of the data. The thing is that the KZG cryptography is required as trusted setup, similar to some snarks or ZK proofs, right? So the KZG commitments required a trusted setup ceremony to create it's called structure difference string, basically secret value, which cannot be, you cannot trust one people to have it. We created in a ceremony of thousands, it was like 100K, more than 100,000 contributions. And the assumption here is that if at least one of those 100,000 contributors did not keep the data they contributed, the whole setup is secure. So honest assumption of one is very secure. And what I did is that I created this device called Catropy to harvest entropy from cats. Because cats are a great source of entropy, they cannot lie, they cannot keep their data, right? So I give them a toy which has a chip inside. It takes the movement data, and this random data are then used to secure Ethereum. So if you're ever going to use layer 2 in the future in Ethereum, you can say that it's secured by like roughly 20 cats. And these are cats from Barcelona, actually. This is a place in Raval called Garden of Cats. Garden of Cats, it's next to the hospital in Raval. It's a beautiful, lovely place. I recommend visiting, but I think to them they're lovely, so they borrowed me some kitties to secure Ethereum. Denkun back scales the blob space. That's the idea for Denkun. We will have more effective way of handling the layer 2 transactions, which means that the layer 2s will get cheaper. The optimism and optimistic ZK rollups will have better way how they store the data, because when you use the layer 2, the main price that you pay is for the storage on Ethereum, which gets expensive as the gas prices go high. But now it gets 10x cheaper or something. So the transactions on layer 2 can be a few times cheaper than now. So yeah, we can scale the space. Search of the layer 2 data came. Yeah, cool. Another upgrade I want to looking, if you're interested more into the technical side of Ethereum, another important thing on the roadmap which is feasible is Merkle trees, or it's short for Vector Commitment Merkle Tree. Currently, Ethereum is using MPT, Merkle Patricia tree, and vector commitments are connecting the leaf nodes using vector commitments. Like the Merkle tree uses vector commitment to connect the leaf node, which enables generation of a witness of a proof that you are included in the tree, which is much smaller than with the MPT right now. And this enables stateless verification of Ethereum. This enables what we've been working on, or like hoping for many years, stateless Ethereum. So you can have a Ethereum client which acts as a light client. It's very small, and it can still connect to the Ethereum network and verify its data even with small resources, maybe on your phone. So yeah, you can learn more about it in the info, and it's an elephant because they uproot trees, right? So we're gonna get rid of the old tree. We will have a new vertical trees, and this is how it looks in the context. So like this is what Vitalik posted like a year ago. Some of it is already further, like the withdrawals are done, for example, in the merge, but this is the main proof of stake part. Another interesting thing happening is single slot finality, because currently the beacon chain, the Ethereum consensus, the proof of stake, is using what we call LMD Ghost, Ghost with Casper, and it's this proof of stake mechanism which enables that even if you have some part of the network down, it still continues, still makes blocks, even if you don't have finality. So that's it's secure, but it's like it's kind of like weird trade-off there. So currently in the research is single slot finality, which would enable the security of finalization instead of like 6 minutes something, as it is in 12 minutes as it is in Ethereum right now. It would be 12 seconds. So that's in research. The search is the sharding that I was talking about. Scourge is about MEV and about enshrined PBS. Proposal of separation. So we are trying to solve, like somehow make protocol to handle the minor acceptable value, because it's MEV problem, right? The verge is the vertical tree that I was talking about, and verge is about historic expiry, which is also in progress. You see, we are banning the self-destruct successfully. And the idea here is that the old data, which Ethereum doesn't need anymore, can get safely purged without losing anything valuable and so on. So again, it will be easier for users to verify the chain and independently use Ethereum privately, securely. So yeah, it's shorter the roadmap, and it's tough, it's complex, as you can see all these crazy words, because we are trying to fit in this triangle. The decentralization dilemma of the blockchain networks, where we try to make it scalable and secure, decentralized, and you always end up in one of the corners. And Ethereum is never wants to sacrifice the decentralization part, so then it looks like this. Yeah. However, it's not. It won't go forever. On one hand, the developers, they would call Ethereum an infinite garden, or like infinite game, right? You play it for playing it, not for winning. So always trimming the hedges in the garden. But what we hear more and more is ossification, that we need to get to the Ethereum design, where we can actually ossify it, enshrine it, and enable only minimal non-breaking changes. That's also in discussion recently. And that's like the world with Ethereum done, maybe, or what used to be E2 at the time, right? But it's a moving target. So one day we will get there. It will look like this. If you're interested in developing, if there are any developers here who got inspired by my talk and would like to learn more about the protocol development and become like core dev of Ethereum one day, check out the ETH Protocol Fellows Protocol Fellowship, which helps people to become core developers. And that's all, folks. Thank you so much for coming to my talk. And, I think we have room for questions, I guess, if there are any.
Just a quick, not protocol specific, but there's a huge centralization of the nodes, like IDS nodes and stuff like that. There's these charts. How it correlates with the protocol centralization of who owns the nodes, like the decentralized companies.
Well, the companies, right? Like, I mean, it's kind of like a standard in the world. It's so like when you are a big company and you want to start a node, if you want a server, you tell your DevOps guy is going to use Terraform to spin some AWS server, right? They have like processes for this. So like if you're a big company, you get into using or staking on Ethereum, you end up just spinning the virtual servers. So many of these, same like Bitcoin nodes and all the kind of. So actually, what is happening here is that like with Ethereum node requirements being relatively low, it's cheap to run in the cloud, right? Because if it's huge, then it's cheaper to get a physical server, which like you pay once and you need to pay monthly a huge price, right? So so yeah, there is a bunch of companies which have big part of Ethereum in whatever AWS, DigitalOcean, whatnot. There are a bunch of, so that's a beautiful thing about a proof of stake. Like it encouraged so many people to stay from home. You can have laptop, Raspberry Pi, and you can literally create blocks on Ethereum from your bedroom. So that's very powerful and yeah, helps in centralization. Yeah, yeah, yeah. Any questions? Any ideas? Yeah.
Okay, so in the beginning you said that the point, I mean, it's obvious that Ethereum is made to be an operating system, basically for the Web3 world. Having said that, which is the path do you think Ethereum is going to scale the most in, considering NFTs, gaming, apps, payments, anything?
What do you mean, like what use case will be dominant on Ethereum?
Yeah, in the future, maybe what path will be the most prominent?
I don't know, like it's up to the market. Like if you look, there is a nice chart that somebody did in like 2019 of like different narratives on Bitcoin and Ethereum over the time. And there is like a bunch of things which we saw in the beginning, and then they were more popular, less popular. So like NFTs were big few years ago. Now there is a bunch of DAOs, DeFi, and whatnot. Like for like I can speak subjectively. I cannot tell
Yeah,
like
exactly.
what market will bring. So like subjectively, like the open permissionless finance is very strong, very important, and like so as I finished high school when I was 19, I closed all my bank accounts and I just get all my salary in Bitcoin and crypto since then. And it's very hard to live without a bank account if you don't have Ethereum. So this permissionless way of finance enables people like me, the crypto people living in parallel economy, to manage their finances more effectively. So that's very important. But yeah, like generally, I can see like the DAOs being useful, used as well. But you know, it's like the point of the Ethereum being neutral and just like anybody can build whatever they want. And personally, what I would like to see is more privacy, more private transactions. Like to me, I talk about the KZG commitments. My ideal case would be that like Ethereum is only like every block is just like one big ZK proof or commitment to some invisible data full of transactions of people that you don't know what they're doing, and that's what I hope. I don't want to know what's happening. I just I just wanted to run and be secure and private. Yeah.
Thank you.
It's on. Okay, cool. So I just wanted to ask about ossification. By the way, I had to look up the word. It means bulk formation apparently, for those of you who didn't know. What do you mean exactly by that? So
yeah, I was a bit speedy in the end because I was like running out of time. I'm sorry about the quick finish there. But so ossification in this case would mean that we ossify, like we consider some version of Ethereum, some specification of it, and this implementation as sort of final, unchangeable. We don't, like right now we do many fundamental, very strong changes in protocol. As you can see, we add opcodes, we remove opcodes, which is crazy. We add these precompiles and so on. So like changing how the consensus works, those are very, very strong changes. So the idea of ossification is that like if we do these important changes and the research doesn't get us to a point where there is like this risk aversion, right? There is it's not worth the risk to do some fundamental changes to the protocol, like 90% change for 10% benefit, right? Kind of thing. Right now we are doing the changes because the risks are not that high and we still we want to improve it. But we will get to a point where it's not so worth to improve, and we are kind of happy with the version of the protocol, and we consider it sort of final, ossified, and we there will be still maintenance, still bug fixing, still optimization, and some small changes, I guess. But the idea is like don't make more breaking changes at one point in the future. Like it's still far, I would say. Still many things to solve, many problems to solve. But it's good that people are talking about it. Yeah, yeah. So it's like in early stages of discussion right now.
Thank you.
Yeah, sure.
You spoke a lot about openness, openness, permissionlessness, and stuff like this. What's your opinion, personal opinion, about the OFAC and ADBwatch.com, like the number of censored transactions? Does that go against Ethereum design principles?
So like it doesn't, because again Ethereum is neutral. It cannot like tell the block proposers how they should behave. So like if the block creator, whether it's miner or validator, decides that he doesn't like these transactions, like it's up to him. So what Percol can do about this is to in the roadmap, in the scourge part. So the ensure proposal the separation and censorship resistant lists, CR lists, are like inclusion lists, creating kind of a private mempool where you would enforce inclusion of certain transactions which just pay the base fee. So like there is a way how to make sure that transactions will go in. So like talking from like general perspective, it's not nice. What we see that the community embraced it. The community talked about it a lot, and the OFAC adoption went from like 70% to 30%. So it means that like every third block is censored. Even if it's like 80, it means that it's every fifth block. So you wait 1-2 minutes to get to the transaction. So it's not end of the world right now. It's not such a priority, but the research is there, and the research is about the application layer MEV minimization using these inclusion lists. And what we right now, the proposal that is being like tested is called Enshright Percol build separation, and that enables this. It's still kind of early, and honestly, it doesn't solve anything. It doesn't solve everything, but it's like being researched how to make it better. Yeah, but it's not ideal. Yeah. Cool. I think we're out of time. Are we not? Maybe one more question, if there is any. Super. Love the name T-shirt, by the way.
Thank you, sir.
Surely.
I was reading, obviously, Vitalik talked about self-addresses some time ago. You know, like what progress is there, and also in general, Ethereum Foundation, how they approach privacy. If you guys discuss it often, like how does it work?
So when I joined EF like 3.5 years ago, like 3 years ago, it was one of my first research projects. Was about end-to-end privacy, and I was so lazy because I didn't like the situation and didn't finish it on the guy. Yeah, so there is some research on it. There are stealth addresses which work. It's called Umbra cache. That's like application layer. And what is being researched is this new proposal. So there is a guy, Toby Nero.eat. He's a researcher from EF who made a proposal for stealth addresses as EIP, and it was discussed research. And now there are some Percol fellows who worked on his work. They created the stealth addresses using fully homomorphic encryption, which is even quantum resistant. It's a pretty cool proposal. I can show you. You can find this in this repository. Where is it? You can find it right here. In this repository under projects, you can find the stealth address proposal, which we are like now testing, doing some like implementation to make sure that it's like, because the full homomorphic encryption is pretty computationally heavy, so they want to make sure it's actually doable on Ethereum and might become a broken file. The challenge there is implementation wallets, because you need extra key. You need a key for encryption, decryption of the encrypted messages for the homomorphic protocol. So basically, your MetaMask or whatever would need to handle like extra pair of keys. So it might be more complicated to get it supporting wallets, but it seems the proposal itself is nice. The proposal seems to work. Yeah, it's in the repo. Yeah, the guy who works on this is called Mason. Yeah. Cool. I think that's it, folks. Thank you.